Okay, so for that first one, what do you think? I don't want that. What do you think we could say the x-axis, first of all? What do we have to make sure we include in our situation? What's going on? Time. And the y-axis, what do we have to make sure is included in our story? Temperature, okay? Okay. So now, let's go, and we'll just do this right on the graph so we have room to write our story and the rest of the white space here. What's happening there on that part of our graph? What kind of words could we use to describe that? Yeah, stays the same. Remains constant. We can just say stays the same. How about that, where we have that next line segment that is falling from left to right? What do we say there?
Decreasing sharply.
Okay, decrease sharply. Okay. Okay. How about, now we have this little section. What should we say there? Stays the same again. Okay. So something, whatever it is in our story, when we are describing it, something's got to not change. Okay, and then we have our last one here. What should we say there? Increases steadily. Okay, increases steadily. Okay. So I'm going to write a situation for this. We have temperature versus time. So the temperature of something, we just got to talk about something that has temperature. And that temperature, we're going to talk about how it's changing over time and how it's changing using those kind of, situations also. So anybody want to have something to start with? Jossie?
The temperature stays the same, and after a while it drops, and it stays the same at that temperature that it dropped to, and then goes back up.
Okay, so it kind of sounds like we're talking about temperature outside. Is that what we're talking about, or? So let's just take that story now and just jazz it up a little bit. Let's add some more like visual to it, like what's other than just the temperature. Right now, all I'm seeing when we say the temperature, I'm just visualizing a temperature gauge, and that's all. Let's get it a little more colorful. But I like your start. What can we add to it, Noah?
When the sun set, the temperature stayed the same, but when it was dark out, the temperature dropped.
Okay.
And when the sun was rising, it stayed the same, then the temperature increased.
Okay, so now we've taken it, we've kind of placed ourselves into something that we can have a more of a picture of. So he said, at sunset, right? Is that what you started it as, Noah?
Yeah.
Okay, so at sunset, as Jossie said, the temperature remained the same for, we gotta talk about, there's some time that's going on there, so should we say for a short while or a long while, or should we say for about an hour? Okay, for about an hour. And we're going to stop there. We don't want this great big long run-on sentence that turns into, our situation can have more than one sentence. Okay, so we've just described that first part. At sunset, the temperature remained the same for about an hour. And then what did you say next?
A couple minutes later, came out and the
So the moon comes out about an hour after the sun sets? Okay, so the moon comes out, we'll say came out because we were already talking in past tense. So the moon came out and for the next short period of time, can we say? It doesn't look like it lasted for very long. For the next short period of time, you're not writing as big as I am, because I'm going to run out of room. For the next short period of time, the temperature decreased sharply. End of sentence. That's a long enough sentence. Okay. Throughout the night. Or how about we say throughout the next few hours? Can we do that? It doesn't look like it lasts real long, so how about we say throughout the next few hours, the temperature, you know what, let's use a different, instead of saying remain the same, let's be, like really get good with our story here. The temperature stayed constant. Now let's show that we have quite a vocabulary. After that, what happened? Let's kind of wrap this up because we've already taken up a lot of room, right? After that, the temperature increased steadily, right? Okay. After that, the temperature increased steadily. Okay, so do you think tomorrow I'm going to take like these little about 8 words of a situation or something like this? Probably not. I'm going to say, I don't think you gave me enough effort. I want you to show me that you have some good writing skills also and an imagination. And so anybody have any questions about anything further on that one? Now, I think it also told us to do something else. Tell whether it was discrete or continuous. What kind of a graph do we have here? Continuous. Let's write it under the graph. We have a continuous graph. Okay. That. It's continuous. In other words, time continually goes on and the temperature is continually changing also. Whether it's staying the same, increasing, or decreasing, the temperature can be measured at any given time. So it's continuous. Okay? Graph B. Okay, our first move is to say, you know what? I got to talk about what? Subway cars, right? In my story, I got to be talking about subway cars. And on the y-axis, as I'm going along the y-axis, I have to consider that there are passengers. In my situation, my story here, I better be talking about some passengers on some subway cars. And the subway cars, we move from left to right. So as we get more subway cars, we are going to talk about what's happening to the number of passengers. Okay? So, I think they have, first of all, this is what kind of a graph? It's discrete. So that's kind of important when we're also deciding how do we write the story for this one. It's a discrete graph. So in other words, there's distinct points. There's distinct things happening. So, subway cars, passengers, distinct points. How many points are there? 6. 6 points altogether, right? Right here? We got these 6 points, and they look to be rising at a steady rate, don't they? So in other words, there's no like so much here, so much there. It looks like they're kind of going at a steady rate. In fact, they even have it numbered for us, don't they? They have, oh look at there, 40, and then 80, 120, 160, 200, 240. It kind of looks like when there's one subway car, there's 40 passengers. When there's 2 subway cars, there's 80 passengers. Is that how we want to write our story though? When there's 1 subway car, there's 40 passengers. When there's 2 subway cars, there's 80 passengers. No, that's a lot of writing. Let's make this into something that describes that though. Modi?
One day of the week we had 40 people on the car. And on the second day of the week we had 80 people on the car.
Okay, but wait a minute. Is there anything in the talk? Wait a minute, let me stop you for a second. Is there anything in here that's talking about days of the week?
No.
Okay, so don't introduce a new thing into our situation here. We don't want to complicate this. Julia?
As the number of subway cars increases, the amount of passengers.
Is it doubling every time? 40 to 80, that's a double. How about 80 to 120? Is that a double?
Yeah.
No, I don't think so.
Just goes up.
It's going at 40 at a time, right? How can we say that? So how did your story start before then?
As the number of subway cars increases, the amount of passengers increases by 40.
Okay, so let's just expand on that just a little bit. So she says, as the number of subway cars increases, the number of passengers increases by 40. Has anybody ever ridden on the subway? Mrs. Allen has back there, so have I. You have too, Jesse, especially if you've been out on the East Coast. That's very popular transportation out on the East Coast. So
They also have subways on airports.
yeah, sometimes you have to take a tram. They call it a tram, right? Over to another part of the airport, and those are like subway cars, absolutely. Okay. So let's just say that we have a subway train. Let me help you out here. A subway train, according to this graph, has how many cars? No. How many cars? 6 cars. A subway train has 6 cars. That's what this graph is showing us. And we can say each car holds how many passengers? 40 passengers. And you know what? That's all we have to say. Each point represents a car, and then it has another 40 passengers in it. So when you look at the graph, you say, oh, when there are 2 subway cars, that would mean there are 80 passengers altogether in just those 2. When there are 5, there are 200 passengers altogether on this subway. Okay, so good thing we had a little bit shorter story this time. I went into my extra space. Okay, go ahead and get this one started. Graph C. What do you have to do? What will you do on a problem like this in your homework? What do you have to do first? And then, if this is, what kind of a graph is this? Continuous. When it's continuous, what else do you need to do? Remember this? There are 3 pieces to that graph. Each piece has its own thing going on. Okay, so do you agree, we all agree that the x-axis is showing us time and the y-axis is showing us distance from home? How about that first line saying what's happening there? What's increasing steadily there? It's actually distance from home is. Remember when we talk about something increasing, we're looking at the y. So that's increasing steadily. Yes?
The one that stays the same could be like he stopped somewhere to fill gas.
Yeah, because no distance is going on, so we're going to say that part stays the same. So yeah, in our story, there's no distance happening, but time is still going by, right? Okay, and then the last one, what's going on in that one? Decrease steadily, okay. Okay, so Cody here has kind of got a start of a story going for us. He's somewhere he stopped with gas, okay? We got to start the story though. So distance from home. It starts at 0, so where are they at when they start?
The garage.
Yeah, there's the garage. They're at home, aren't they? They're in the garage or on the driveway or on the street, wherever they have to park their car. So starting from home, we're gonna start from home. What's gonna happen? Where are we gonna go? And then,
They need to fill gas, so then leave it at the gas station.
okay, but so Cody,
The car is at home. He goes to the grocery store, get groceries, and then he goes to the gas station nearby, and then goes home.
Well, if you stop for groceries, that would be another one.
okay, let's see. Wait a minute. If you drive to the grocery store, are you getting further away from home? Would that take up that first line segment? Okay. Then you buy some groceries. Are you getting further away from home while you're buying groceries? No. And then Cody says you're going to drive to the gas station.
Walk to the gas station.
Why are you going to walk to the gas station? You need some gas?
But what if the gas station is connected to the grocery store?
Well, then we got to say that. So we're going to a grocery store,
Costco.
convenience center also. So we're going to Costco where they have the gas pumps too?
Yeah.
Oh, okay, so we're going to go to the grocery store. We're going to go to Costco and get groceries and gas? Okay, so we drive to Costco. We get some groceries and some gas. So apparently we're leaving our car parked at the gas pump while we're getting groceries. How about we just do one or the other?
You drive to the gas station, you stop and fill up for gas, then you drive.
Okay, so now notice how long that time is. So what's going on then? So it doesn't look like you drive a whole lot. You don't necessarily have to drive a whole lot of distance, so it doesn't take you very long to get there. But apparently it takes you a while at the gas station. Julia?
You drive to your friend's house, talk to them for like 2 hours and
And then you drive back home. Do you like that story? Or we can stay with the grocery. Okay, why don't you write a story? Go. Okay, you write your own story. I don't need to tell you what to write. Kind of the story of my day. Except oftentimes it's 12 hours, these days it's 10 because I'm taking care of my parents. So I drove to school this morning, parked my car on Central Avenue. I left 10 hours later and drove back home. Does that match that graph?
Yeah.
Yeah. Okay, let's hear some more stories. Okay, Cody, what was your story?
I left my house to go to the swimming pool, and after 3 hours, I went home.
Okay. I left my house, go to the swimming pool, and after 3 hours, I went back home. Another one. You know what?
Man is leaving his house to go see his family, and as he gets to the off ramp, his speed increases, and it stays the same until he has a flat tire, and his speed decreases.
Anybody hear anything about Noah's story that he better change or it would not qualify as accurate on an assessment? It says he's driving to a friend's house and he got to an off ramp and his speed decreased, increased, and then
And then when he was on the highway, and then he has a flat tire.
he was on the highway and then he had a flat tire. What's wrong with that? Why would I have to take that apart and say, no, they don't understand? What's wrong?
Well, but then, like, if he's already driving and he like starts driving again, like more miles.
Okay, so he's driving and then he's driving again, you're saying, and so wouldn't that take his distance further away from home? He hasn't turned around and gone back home? Yeah, that's one of the issues. Cody, what's another possibility?
He showed that his speed increased, and then
Is speed a part of this? Is speed involved in this story? No. If you're gonna say something about speed, it has to do with, so if this one increased a lot more sharply than this decreased, then I might say, I left home this morning and drove to school in a hurry. Then I stayed there for 10 hours, and I drove back home at a more tired pace, teaching all day. So there's really no speed involved in here. We can't talk, the lines are not showing speed unless you're talking only about how fast they're increasing or decreasing. So your story does need to be changed there, Noah. So if you want to steal mine, you can, or somebody else. Does anybody else want to share their story yet before we call it quits here? Justin?
I wanna see if this will work.
Okay, that's a good idea.
Starting at home, I drove to my friend's house and stayed there for a few hours. When I was ready to leave, I drove.
Yeah, that's a good one. She drove, got further away from home, went to a friend's house, stayed there for a few hours. Her and her friend didn't get in the car and drive around, it all didn't sound like. And then she got in her car and went back home. So notice, because these two are exactly the same height, can you go another distance? And further, you go somewhere, you remain there for a while, wherever it is that you're at, you remain there for a while, and then you drive that same distance back home again. Okay? So you can't go anywhere else along the way. Okay, good.